This is the continuation of the worksheet. The other video, I only had one problem there because I was still trying how this video works. But in this video, I will be answering or showing how to answer the rest of the problems. Okay, so for this one, we can see that there is a person that is on a parachute and the person is accelerating upwards, right? So we can see it from the free body diagram that going upwards is higher than the one going down. And then also, based on the given, we can see that the object is accelerating upward. Okay, so like before, we can calculate the net force, or we can calculate the force of gravity first. So for the force of gravity, it is mass times acceleration due to gravity. Our mass is 800 kilograms, and the force of gravity is 9.8 meters per second squared. Then your answer should be 7,840 newtons. The direction is going downward. Okay, next we can calculate the net force. Okay, again, there are two ways to get the net force. First is you look at your free body diagram, look at the magnitudes of the forces given, look at the direction. If the direction of the forces are the same, add the magnitudes of the forces. If they are not the same, subtract them. Okay, but in this case, we are only given one of the force. We don't know the one of the forces. We don't know the other force, so we cannot use that method. Now we can use the other method wherein we can use the Newton's second law equation, which is net force is equivalent to mass times acceleration. And we can use that one because we're given the mass, which is 800 kilograms, and then we're given the acceleration, which is 6 meters per second squared. If we multiply these two, this is equivalent to 4,800 newtons. And since it is accelerating upward, our net force is also going up. Right? Now, we now have the net force. We have the force of gravity. We can calculate the force of air. Okay, we can just use analysis, or we can just use the math. Okay, but we need to when we're using the math, we need to assign a sign to the direction of the forces. So let's say going up will be positive and going down will be negative. Okay, so for our net force is the combination of these two. Our net force is going up, so we're gonna have a positive net force, and then we have the force of air as positive, and then the force of gravity is negative. Okay, so after that one, we can rearrange this one. You can use our algebra, or for those who don't want to use to arrange first, you can plug in the values and do the math later on. So our net force based from our calculation is 4,800 newtons, and then we need to look for the force of air, and then we subtract it with the force of gravity, which is 7,840 newtons. Then do the math. F air is equivalent to 4,800 newtons plus 7,840 newtons, and this one should be equivalent to 12,640 newtons. Okay. Okay, and it makes sense because this one should be bigger, oops, not straight, than this one, right? This is 12,640, this is 7,840 newtons. Okay, so that's the second one. Third one. Okay, it will be the similar thing, but this time we have forces on both x and y axis. Okay, but the process will also be the same. So we can always calculate force of gravity if we're given the mass, and we're given the mass here. It is 2,000 kilograms multiplied by 9.8 meters per second squared. And the value of the force of gravity should be equivalent to 19,600 newtons. Okay, next thing, we can calculate the net force. Okay, we have seen here that the acceleration is going to the right. Okay, so our net force would be mass times acceleration, 2,000 kilograms, multiplied by the acceleration of the body. You're not using 9.8 here. 9.8 is used to get the force of gravity. If we multiply this 2, it's 4,000 newtons. And our force is going to the right. Okay, so based from here, our force or acceleration is only going to the right. They're not saying that it is accelerating upward or downward. So it means if it's not accelerating upward or downward, the downward force should be equivalent to the upward force. And with that, we now know that our normal force should be equivalent to force of gravity. So this one should be 19,600 newtons also. Okay, now for the force of friction, since we know that our net force is just going to the right, we have a total of 4,000 newtons going to the right. Okay, so if it's going to the right, this one should be longer, relatively longer compared to this one. Okay, so we should be getting a smaller force of friction compared to this one. Okay, you can just do the analysis, and then you can see if you need to add or subtract these two, or you can always do the equation. Okay, we're gonna assign now going to the right as positive, and then going to the left is negative. So our net force is going to the right, so our net force is positive, and then our applied force is positive, and then our force of friction is negative. Okay, and what we need is the force of friction. Okay, so if we arrange this one first, force of friction using your algebra is equivalent to the force applied minus the net force. Okay, so our force of friction is equivalent to the force applied, which is 14,000 newtons, and our net force is equivalent to 4,000 newtons. So the magnitude of your force of friction should be equivalent to 10,000 newtons. So this is 10,000 newtons. And it makes sense, again, going up or down is equal. If you consider these two, they are opposite direction, you are subtracting them, and this one is bigger than the other, it will give you 4,000 going to the right, which is the same net force that you calculated earlier, right? Okay, the last one. So this one, it will be the opposite. Now, instead of giving the mass and the acceleration, you need to calculate the mass and acceleration. So what we have here is they give you all the forces that is acting on the body. Okay, so for the net force, look at all the forces acting on the body. Okay, but you should not be doing it like 40, something like that. You don't know if you're gonna be adding or subtracting it. You need to separate the y-axis and the x-axis. Okay, so if you look at the force going to the y-axis. Okay, if you look at this one, forces going to the y-axis, we have force going up 40 and force going down, that is 40. So they are opposite direction, you're subtracting them. So what is the force of the y-axis? It should be 0. There will be no force on the y-axis. It means your object is not accelerating up or down. Okay, now let us check the x-axis. So for the x-axis, we have one going to the right, that is 44 newtons, and then one going to the left, which is 28 newtons. So they are opposite direction. Subtract them. Your answer is 16 newtons. Okay, so since you do not have force in the y and you do not you only have force in the x-axis, then therefore your net force is equivalent to 16 newtons. That is the net force of your system. So it's 16 newtons. And then what is the direction? Since this one is bigger than the other one, it is going to the right. Okay, now for the mass. How are we going to calculate the mass? Based from the Newton's second law, and we know that Fg is equivalent to mg. It's the same thing, but now we are very specific that we are using the force of gravity. We can calculate the mass. So if you arrange this equation, divide both sides by g, then our mass is equivalent to Fg over g. Our Fg is 14 newtons. Our acceleration due to gravity is always 9.8 meters per second squared on Earth. And if you divide this 2, you should be getting 4.08 kilograms. And then that is our mass. Alright, now we can calculate the acceleration. Why? Because based on Newton's second law, we can calculate the acceleration. Okay, I'll just put right here. If you arrange that equation, acceleration is equivalent to the net force over m. We know the net force, 16 newtons, divided by the mass that we just calculated. Then your acceleration should be equivalent to 3.92 meters per second squared. 3.92 meters per second squared. And then what is the direction of the acceleration? It is going to the right because the force here is greater. Okay, that's it.